Another new enhancement with version 9 of the Tycho software is that the signal-to-noise ratio, the SNR formula, has been dramatically improved upon. So a while ago I had received an email from another fellow Tycho user, and he sent me this animation, and he pointed out that as he stacked these images together, that the SNR value was not appreciably increasing. In other words, one would intuitively expect that as you produce a cleaner picture, as you improve the presentation of the object, that the SNR value should increase. And I can go into some detail explaining why that's not the case, again with that older version, but suffice to say the new version adopts a much better formula. And you'll also notice, again with the older version, you had these different SNR values. So you had SNR object, SNR logical, and so forth. That has all been cleaned up, and it now adopts just a single SNR value. And so here what you're looking at is this is what the old formula was, and it was actually more or less correct, again, when you had just a single image to work with. It took into account the flux of the object, the sky background noise, the gain of the camera, readout noise, and so forth. But it really did not work so well with a stack of images. Here now you'll notice this is now the new formula used by the new version of Tycho, and what's different about it critically is that it actually makes use of the standard deviation, if you will, of the noise. So whenever you stack images together, you're actually not really increasing the signal of the object. What you're really doing is you are reducing the, if you will, again, the standard deviation of the noise. So the background noise might average out the same, but you've really, again, improved upon that presentation. So here's the new formula adopted by the new version. So you have SNR is equal to flux divided by square root of flux with the gain parameter adapted. And then you also take into account the standard deviation. So square of standard deviation multiplied by the number of pixels in that aperture. So this works out as follows. So given this object above, we have, again, the flux value and the gain parameter. I'm just using 1 here. Anyway, this produces 3.08, and then as we increase it, we stack images together, you can see this improvement. So now we have 5.38 compared with 3.08. So you'll notice it now actually does have an improvement in SNR when you stack images. So this is again adopted by the new version of Tycho, and what's nice about it is now we just have a single formula for SNR. We don't have to have SNR logical and SNR object and so forth. So here again, old formula, single image, it would say, as an example, 9.6 with a stack of 60. There was really no appreciable improvement, so 10.84. Whereas with the new formula, again, the same object, it now takes into account the actual improvement in the background noise. There has been a reduction in that standard deviation component. So now single image might again have something like, in this case, 8.76, and stack of 60 images, now you have SNR 42.5. So you actually notice a noticeable improvement with that stacking process. So anyway, just something to keep in mind. Now Tycho, the SNR formula used by Tycho actually now takes into account this improvement factor whenever you stack images together.